Input design and prototyping.
Methods and issues for data capture and input. To input business data into a computer, the analyst may have to design source documents, input screens, methods, and procedures for getting the data into the computer. Data accompanies business events called transactions. System analysts must have determined when and how to capture the data. Now, let me go to the data capture and data entry. So, data capture, what does it mean? Data capture means identification of new data to be input. It is always best to capture the data as soon as possible after it is originated. Traditionally, special paper forms called source documents were used to capture the data. A source document is a paper form used to record data that is eventually be input to a computer. With advanced in-video display technology, screen display forms are able to replicate the appearance of almost any paper-based form. Screen display forms and source documents must be designed to be easy for the system users to complete and should facilitate rapid data entry. Data entry is the process of translating the source document into a machine-readable format. That format may be a magnetic disk, an optical mark form, a magnetic tape, or a floppy diskette to name a few. Now I go to data processing. The processing is all processing that occurs on the data after it is input from a machine-readable form. And there are three kinds of processing. The first one is the in-batch processing. The entered data is collected into files called batches and processed as a complete batch. In online processing, the captured data is processed immediately. And the last one is the remote batch processing. Data is entered and edited online, but collected into batches for subsequent processing. Let me go to input implementation methods. How to implement the input? You have many ways. The first one is a keyboard. Data is entered via keyboard. This is the most common input method, but also the most prone to errors. The second is the mouse, used in conjunction with keyboard to simplify data entry. Mouse serves as a pointing device for a screen. The touchscreen data is entered for a touchscreen display or handheld device. Data entry users either touch commands and data choices or enter data using handwriting recognition. Now the point of sale terminals. Next is the sound and speech. You can get the sound to work with the sound, speaker, or voice. You can have automatic data captured by optical mark recognition like barcodes, optical character recognition, magnetic ink. A magnetic ink readers read the magnetized data. The customer added data must be entered using another input method. Electromagnetic transmission data is transferred by radio frequency. Smart cards data is read by smart card readers. Biometric data is read by biometric sensors. Primary application are security and medical monitoring. System user issues for input design. Input should be as simple as possible and designed to reduce the possibility of incorrect data being entered. The following general principles should be followed for input design. Capture only variable data. Do not capture data that can be calculated or stored in computer programs. Use code for appropriate attributes. If source documents are used to capture data, they should be easy for system users to complete and subsequently entered into the system. The following suggestions may help. Include instructions for completing the form. Minimize the amount of handwriting. Data to be entered or caged should be sequenced so it can be read like this book, top to bottom and left to right. Ideally, portions of the form that are not to be input are placed in or about the lower part portion of the source document. GUI controls for input design. Most new applications being developed today include a GUI. This approach is influenced by a new trend in programming called repository-driven programming. Text box. A text box consists of a rectangular shaped box that is usually accompanied by a caption. It requires the user to type the data inside the box. A text box can allow for single or multiple lines of data characters to be entered. When a text box contains multiple lines of data, scrolling features are also normally included. When to use text box for input. A text box is most appropriately used in those situations where the input data values are unlimited in scope and the analyst is unable to provide the user with a meaningful list of values from which they can select. Radio button. A radio button consists of a small circle and associated textual description that corresponds to the value choice. The circle is located to the left of the textual description of the value choice. Radio buttons normally appear in groups, a radio button per value choice. When a user selects the appropriate choice from the value set, the circle corresponding to that choice is partially filled to indicate that it has been selected. When a choice is selected, any difficult or previously selected choice circle is deselected. When to use radio buttons for input. When a user is expected to input the data that has limited predefined set of mutually exclusive values. Checkbox. A checkbox also consists of two parts, each followed by a textual description of the input, field for which the user is to provide the yes or no value. Checkboxes provide the user the flexibility of selecting the value via the keyboard or mouse. An input data field whose value is yes is represented by a square that is filled with an X. The absence of an X means the input field values is no. The user simply toggles the input values from one value state to the other as desired. When to use checkboxes for input. When a user needs to input a data field whose value set consists of a simple yes or no value. Last box. A last box is a control that requires the user select a data item's value from a list of possible choices. The last box is a rectangular shape and contains one or more rows of possible data values. The values may appear as either as textual description or graphical representation. List boxes having a large number of possible values may consist of scroll bars to navigate through the row of choices. A list box row may contain more than one column. When to use list boxes for input. A list box scrolling capability make it appropriate for use in those cases where there is limited screen space available and the input data item has a large number of predefined mutually exclusive set of values from which to choose. Drop-down list. A drop-down list is another control that requires the user to select a data item's value from a list of possible choices. A drop-down list control consists of rectangular shape selection field with a small button connected to each side. When to use drop-down list for input. A drop-down list should be used in those cases where the data item has a large number of predefined values and screen space availability prohibits the use of a list box to provide the user with a list box. One disadvantage of a drop-down list is that it requires extra step by the user in comparison to the previously mentioned controls. Combination or combo box. A combo box combines the capabilities of a text box and list box. A combo box allows the entering of a data item's value as with a text box, or by selecting its value from list as with a list box. When to use combo boxes for input. A combo box is most appropriately used in those cases where limited screen space is available and it is desirable to provide the user with the option of selecting a value from a list or typing a value that may or may not appear as an option in the list. Spin or spinner box. A spin box is a screen-based control that consists of a single line text box followed immediately by two small buttons. The two buttons are vertically aligned. Top button has an arrow pointing upward and the bottom button has an arrow pointing down. This control allows the user to enter data directly into the associated text box or to select a value by using the mouse to control or to spin through a list value using the buttons. When to use spin boxes for input. A spin box is most appropriately used to allow the user to make an input selection by using the buttons to navigate through a small set of meaningful choices or by directly keying the data value into the text box. The data values for a spinback should be capable of being sequenced in a predictable manner. How to prototype and design computer inputs. Step 1. Review input requirements. The design unit depict input to be designed. This input are represented as data flows that connect external entities to process. Review the required attributes of data inputs. For each attribute, the designer must identify the appropriate caption or label they will use to clearly identify to the user the attribute appearing on the screen. The size and edit mask or format of the attribute must be predetermined. Step 2. Select the GUI controls. To choose the correct control for our attributes, you must examine the possible values for each attribute. Step 3. Prototype the input screen. This step involves developing prototype screen for the user to review and test. When prototyping input screen, it is important to actually let the user exercise or test the screens. Prototypes should demonstrate to the user how security will be handled. Prototypes should demonstrate how error handling will be accomplished. Step 4. If necessary, design a prototype the source document. If a source document will be used to capture data, we must also design that document. The source of document is for the system user. A well-designed source document will be divided into zones. Some zones are used for identification. These include company name, form name, official form number, date of last revision, an important attribute that is often omitted, and logos.